Welcome to qnawire.
Okay, so as humans continue to burn fossil fuels, the amount of CO2 in the atmosphere increases. Scientists measure atmospheric CO2 in parts per million, which means the number of CO2 molecules for every 1 million molecules of other atmospheric gases such as oxygen and nitrogen. Scientists have been tracking the amount of CO2 in the atmosphere at the Mauna Loa Observatory in Hawaii since 1958. So here's the table that you had provided, and it says that you need help answering these questions. So it says use the data to make a summary table of the mean CO2 level in the atmosphere as measured in Mauna Loa Observatory for the years, and so it wanted you to do it for every 5 years. So I took the data from the table and I made it into a table for every 5 years. And I'm using Excel to help you find this. And it says divine the number of years that have passed after 1960 as the predicted variable X in the mean of CO2 measurement for the particular year is Y. Create a linear model for the mean CO2 level in the Y equals mx plus b using the data points for 1960 and 2015. Round your slope and y-intercept values to 3 decimal places. Use the decimals to sketch a scatter plot of the data in your summary table, and also a graph of the linear model over this plot. Comment on how well the linear model fits the data. Okay, so first of all, I'm just going to copy this and I'm going to paste this. And this is year 0, which makes this year 5. So these are years since 1960. And 1960 would be year 0 because that's when it started. So I'm going to highlight this information and I'm going to insert a scatter plot, which is definitely similar to using the decimals. And I'm going to insert title. So this here is the year since 1960. And the axis title here is the mean. And so then what I'm going to do next, and it wants me to find an equation. And so I'm going to insert a trend line. And here's my trend line, and y equals mx plus b, and round the slope and the y-intercept to 3 decimal places, which, let me just make this bold. So I'll make this a little bit bigger. So this is the regression equation that it came up with. And so for b, we'll call this second one b. It would be y equals 1.537 x plus 310.57. And I already did A, so this would be A here. Bold, and I'm going to just make this. And this is going to be red too. So this is B. And bold. Okay. And then for C, oh, and I'm sorry, I need to also finish answering the question. It says comment how well the linear model fits the data. So the linear model fits the data. Well, because as you can see, as the years increase, so does the mean. And okay. Just make this a little bit wider so we can fit that in. All right, so C, the next part. Looking at the scatter plot, choose 2 years that you feel may provide a better linear model than the line created in part B. Use the 2 points you selected to calculate the new linear model and use the decimals to plot this line as well. Provide this linear model and state the slope and the y-intercept rounded to 3 decimal places. So if I am going to provide 2 points, I'm going to provide 2 points on the line that is the closest. So my 2 points would be the 3rd point and the 5th point. So I'm just going to highlight these. 10 in this one and 20 in this point. And so if I was going to make a table or a new graph, and this is going to be 10, 15, and then I'm going to insert a new scatter plot, and I'm going to why did it flip that way? Okay, so insert scatter plot. Here we go. All right, so my trend line and my equation, my trend line, and I'm just going to bold this to make it bigger. And let's see, I'm going to merge and wrap. Okay, and so this is my equation, except I have to round it to 3 decimal places. So this is going to become a 6 and get rid of this 4. Oop. Sorry, went out a little bit too far. Okay, so here's my new table. And so then it says I used the 2 points. I provided a graph. What we could do, though, is if you would like, get rid of this. And so this is titled the mean. Oh, no, I'm sorry, not mean. Years since 1960. And then this here is the mean. And so here is my new chart here. Oop. And I'll do this again. Trend line. Oops, not exponential. Wrong one. Trend line. Linear. Okay. And my regression equation. And we're going to make this bold and bigger. All right, here we go. So that is my new chart using the 2 data points. Then it says, use the linear model generated in Part C to predict the mean CO2 level for each year's 2010 and 2015. Separately, compare the predicted values from your model to the recorded measure values for these years. What conclusions can you reach based off of this comparison? So 2010 and 2015. So for 2010 is 50 years since 2016. So, I'm sorry, since 2060. So I'm going to do 1.026 times 50, close my parenthesis, plus 4.744. And then for 2015, that is 65 years. So, I'm sorry, 55 years. And so those would be the two means. And so this is in, hold on, 1.0256. And so I used 50 and 55. So it's not completely accurate. Let me make sure that I did that right. 50. Oh, because the starting point, I need to change the starting point. The starting point needs to be at 310.57. That's why. So, so I have 10 and 325.68. That's not correct. And then I have so that's not right. I'm gonna move this down, and then I'm gonna put 0 here. So that's not right. Here we go. Here we go. Okay, so I need to add a trend line. Okay, add a trend line to this. And then here we go. All right, that's more like it. So it's 1.3733. And then 315.67. Okay. And then I'm going to change this 1.373 times 50 plus 315.67. And then I'm going to drag this down, and then this is 55. Here we go. And I just have to fix this, get rid of one of these 3's. Okay, so now this is more accurate. So 2010, I mean, we're right around the numbers. The only one that's more off is the 2015 number. Oops. All right, so that's the chart for C. Okay, now move this away so I can answer the rest of the questions for you. All right, then for the last one, again using the linear model generated in part C, determine which year mean level of CO2 in the atmosphere exceeds 420 parts per million. So what's going to exceed 420 parts per million is, so I'm going to use, this is A, B, C. So here's my equation that I'm going to use. And I can just experiment with this. If I put in my parentheses, use the star, and if I do 60, it would be 398. This one's not right. 50, 55. And then this one's 50. I knew that didn't look right. All right, there we go. So 420, so it's not that. Let's try 65. So this is 65. Let's try 70. That's 70. Let's try 75. So we're working on D right now. So 75. And let's try 80. I think we'll be lucky with 80. Or I'm sorry, or 75. Let's try 75. So hold on. This is 75. This is 80 now. So I would say 80 years. So the year that it will exceed 420, 420 will be by year. So 1960 plus 80 is 2040. So I hope that this video helps. This is the middle school math teacher signing out.